A pipe of 5.25 centimeters internal diameter and 15 centimeters long slides down a vertical shaft of 5 centimeters diameter at a constant speed of 0.1 meters per second. A vertical force of 14.7 Newton is required to pull the pipe back of the shaft at the same constant speed. Calculate the viscosity of oil. Okay, here we have to calculate viscosity of oil which fills the small gap between pipe and shaft. Okay, so here we have a pipe and shaft, and space between pipe and shaft is filled with oil. So first of all, let us draw the diagram of the given question. A pipe of 5.25 centimeters internal diameter. So first of all, there is a pipe. So here internal diameter of the pipe is given. Okay. So here internal diameter of the pipe is, internal diameter of the pipe is 5.25 centimeters. Okay, and 15 centimeters long. So length of the pipe is 15 centimeters. Length of the pipe is 15 centimeters. Okay, this is length of the pipe. Okay, next. Slides down a vertical shaft. This pipe is slides down. This pipe is slides down a vertical pipe. So simply moving up and moving down. Okay, on a vertical shaft. So let us make some difference. So there is a shaft. Inside this pipe there is a shaft. Okay. I'm drawing rough diagram. Okay. So this is vertical shaft. So vertical diameter of this shaft is, how much given diameter? Given diameter 5 centimeters. Okay, 5 centimeters diameter pipe, vertical shaft, not pipe, vertical shaft. So this is vertical shaft. Here pipe is sliding down a vertical shaft and its diameter 5 centimeter. The internal diameter of the pipe is 5.25 centimeters. Okay, the gap between shaft and pipe. The gap between pipe and shaft is filled with oil. So this gap, okay na? So this gap this gap filled with oil. Okay na? This oil acts as a lubricant. Okay. So gap filled with oil, small gap filled with oil, and this is pipe. This is pipe. So at last we have to find viscosity of oil. In this problem we have to find viscosity of the oil. Viscosity of the oil. So denoted by mu. Here mu means viscosity of the oil in Pascal seconds or Newton second per meter square. So here pipe sliding down with a velocity of 0.1 meters per second. So here this vertical pipe sliding down outside this shaft. So here vertical pipe sliding down outside this shaft with a velocity of 0.1 meters per second. And we also given a vertical force. Here we need 14.7 Newtons vertical force to pull the shaft back of the shaft. It means informally we can say that we require 14.7 Newtons vertical force to separate shaft and pipe. Okay, this much force we require. So ultimately we need viscosity of the oil. So how do we get viscosity of the oil? So here concept is viscosity of fluids. So according to Newton's law of viscosity, according to Newton's law of viscosity, from Newton's law of viscosity, shear stress is equal to mu into du by dy. Mu into du by dy. Okay. So using Newton's law of viscosity, we can find viscosity of oil, mu. Okay. Here we need mu value. Here tau means what? Tau is equal to shear stress. Tau is equal to shear stress. So shear stress formula, shear stress is equal to shear force by shear area, area under shear. Okay. Shear stress is equal to shear force by area under shear. So Fs by As. Now tau is equal to Fs by As is equal to mu into du by dy. Here what is du? Here du means change in velocity. Change in velocity of the fluid layer. Okay. Next, what is dy? Dy means thickness of oil film. So thickness, see here gap between shaft and pipe is filled with some oil. So and this is thickness of this gap. This is thickness of fluid layer. Thickness of fluid layer. Okay. So, or thickness of oil film. Okay. So this thickness manaki dy avutundi. So anyhow here we need mu. Now mu is equal to what? From this formula, mu is equal to transpose du by dy. So Fs by As divided by du by dy. Du by dy. So at last, see. So take reciprocal of du by dy. Then mu is equal to viscosity of oil. Mu is equal to, you will get Fs by As into reciprocal of du by dy, dy by du, dy by du. So to find mu, viscosity of oil, we need shear force, shear area, thickness of oil film, and change in velocity of fluid layers, or change in velocity of pipe. Okay. So mu is equal to, according to Newton's law of viscosity, mu is equal to Fs by As into dy by du, dy by du. First, Fs. What is Fs? Shear force acting on pipe. Shear force acting on pipe. Okay, na? So in this problem, shear force acting on pipe is equal to resistance force offered by fluid layer. Resistance force offered by fluid layer. So what is this resistance force offered by fluid layer? See, here pipe sliding down outside the vertical shaft. The clearance between the shaft and pipe and shaft is filled with some oil. So here the pipe moving with certain velocity. So here we applied how much force? 14.7 newtons vertical force on the pipe. So in general, this fluid has some viscosity. Then what will happen? It will try to resist the motion of the pipe, movement of the pipe. Okay, that resistance force is equal to shear force acting on the pipe. Here how much force we applied? We applied how much force? So we applied 14.7 newtons. We applied 14.7 newtons. Here resistance force offered by the fluid layer is equal to amount of force applied on the pipe, because under equilibrium condition, the amount of pulling force or amount of force applied on pipe is equal to the amount of resistance offered by the fluid layer. Rendu equal అయిపోతాయి ఒక స్టేజ్ లో. ఓకే, సో అందుకే Fs దేనికి ఈక్వల్ అవుతుంది? 14.7 న్యూటన్స్ కి ఈక్వల్ అవుతుంది ఇక్కడ. ఓకేనా? సో నెక్స్ట్ we need As. As means shear area. So here we have circular pipe. So shear area, nothing but cylindrical pipe. Here pipe is cylindrical in shape. So shear area is equal to circumference of cylinder, circumference of a pipe, you can write pipe, into length of the pipe, into length of the pipe. So this is formula for shear area in case of cylindrical pipes. So AS is equals to circumference of cylindrical pipe. So pi d. So let us say here d is diameter of the pipe into L. So L is length of the pipe. So diameter of the pipe, how much you given? You given 5.25 centimeters. Okay. And next length of the pipe, how much? Length of the pipe is given 15 centimeters. And also given diameter of the shaft. Diameter of the shaft is equals to, I think, 5 centimeters. Am I right? Yes, 5 centimeters diameter. And also here we need a change in velocity. Du means change in velocity. So here du change. Change in velocity means final velocity minus initial velocity. Initial velocity of the pipe is 0. Final velocity of 0.1 meters per second. You will get du as 0.1 meters per second. And so let us convert. Let us find dy. So dy means thickness of oil film. Thickness of oil film. So thickness of oil film is equal to clearance between shaft and pipe. So dy is equal to, very simple formula, diameter of pipe minus diameter of shaft by 2. Diameter of pipe minus diameter of shaft by 2. So thickness of oil film is equal to, that clearance between shaft and pipe is equal to, then equal avutundi capital D minus small ds by 2. Here D means, what is capital D? Please remember, here capital D means diameter of pipe. Here ds means diameter of shaft. See, here capital D means diameter of pipe. Okay na? Moving pipe. And ds means diameter of vertical shaft. Diameter of vertical shaft. Okay. So let us find dy. What is capital D here? Diameter of vertical pipe 5.25 minus diameter of shaft 5 centimeters by 2. So 5.25 minus 5, 0.25 by 0.25 by 2 centimeters. Units important, centimeters. Let us convert all units into meters. Before that, let us find AS. Okay, let us find AS. Later on, we have to convert all units into meters. Okay. So now AS is equals to area under shear is equals to pi into diameter of the pipe, how much again? 5.25 centimeters into length of the pipe 15 centimeters. So AS is equals to pi into 5.25 into 15 centimeter into centimeter, centimeter square. So let us convert square centimeters into square meters. 1 centimeter square is equal to how many meter squares? 10 to the power of minus 4 meter squares. So now AS is equals to pi into 5.25 into 15 into 10 to the power of minus 4 meter square. Okay. So we have AS and Fs how much? Fs is equals to, so amount of shear, amount of pull applied on the pipe is given 14.7 newtons, and dy means thickness of oil film. We got 0.25 by 2 centimeters. Convert it into meters. 1 centimeter is equal to 10 to the power of minus 2 meters. Okay. Next du how much? Velocity. Okay na. So here velocity is how much given? 0.1 meters per second. Okay. So velocity of the pipe is 0.1 meters per second. Let us substitute all values in this formula. We will get dynamic viscosity of oil. Mu is equal to Fs 14.7 newtons into thickness of dy means thickness of oil film 0.25 by 2 into 10 to the power of minus 2 by the AS pi into 5.25 into 15 into 10 to the power of minus 4 into du 0.1. So now mu is equal to, let us simplify numerator and denominator separately. If you simplify, okay na? So if you calculate numerator value, you will get 0.01875. Okay, so if you calculate value of denominator, you will get approximately, here I got 0.002474. so at last mu is equal to, you will get 7.4272 Pascal second, or 7.4272 Newton second per meter square. So this is viscosity of the oil.